All right, here we go with this example here. Now, notice that in this system of three equations, they're not in standard form. So in this case, we're going to have to write these in standard form. So that's the first thing I'm going to do. This one is already in standard form, but remember, there's no z variables, so make sure that they all line up. So 2x plus y equals -2. And then here we've got a y, x is missing, so we're going to have 3y minus 5z, right? Because I got to subtract 5z from both sides, and that's going to equal -12. And here I'm going to distribute, so this is going to be 5x plus 5z, and then I'm going to subtract off the 2z from both sides, so minus 2z, and that's going to equal 5, right? So x, now there's no y here, so I'm going to have to combine these, right? So this is going to be 3z. So in this case here, it's going to be 5x plus 3z equals 5, okay? And so that's my system of equations that I have, okay? So now I can solve these, right? So now in this case here, oh, I messed up. I accidentally erased, so it should be 5x. So this should be 5x. There we go. Okay, so now in this situation here, what do we got? We've got equations that are missing variables in each one. So what we want to do is, again, we want to eliminate a variable that's going to give us the two variables, and then we want to take another pair of equations that we eliminate a variable that gives us the same two variables. And in this case here, we could pair these two up and eliminate the y's, right? And that'll give us x and z. And if we take these two, well, we can't do anything with it, right? But, well, actually, we'll already have x and z, right? So if we use these two, we'll end up with an equation in x and z, and then we already have another equation x and z. So it helps us in the fact that we don't have to pick another pair, because we already got an equation in two variables. In fact, all three of these are in two variables, but different variables, okay? So as long as we can eliminate one variable, we're good. We could also use these two and eliminate this variable and have x and y, but in this case it's going to be easier to use these two because we've got a y here and a 3y here, so all we have to do is multiply the top by -3. So let's do that, okay? So the first thing is I'm going to do -3 times the first one, which is 2x plus y is equal to -2, right? And I'm going to add that to the 3y minus 5z is equal to -12, okay? So what happens here, I multiply through by -3, this is going to become a -6, this is going to become a -3, and then of course this becomes a +6. And so now, okay, now I can add, and so when I add, I get what? I get -6x, these go away, minus 5z, and then equals -6. Now, I've got x and z here. I've got x and z here. So now I can skip step 3 and go right to step 4. Okay? So step 4 is now let's solve these. So 5x plus 3z equals 5. And so now here, I've got to eliminate one of the variables. Okay? So again, I'm going to have to multiply both equations by a non-zero constant. So let's, here, let's just do the first one. Doesn't matter which one. So let's multiply this by 5, right? And this one by 6. This one's already negative, so we could just do 5 and 6. And so this gives us what? Negative 30x minus 25z equals negative 30. And then 6 times 5, the bottom one will give us what? Positive 30x plus 18z, right, equals 30. And now, when we add down, these go away. This will give us what? Negative 7. No, hold on a second. Yeah, negative 7. So negative 7z equals 0. Well, if we divide both sides by negative 7, well, all we get is what? Well, this is going to give us 1, and then what do we get? We get what? Z is equal to 0 divided by 7, which is still 0. Or negative 7. 0 divided by negative 7 is still 0. So in this case, we get z is equal to 0. Now, if we plug it into one of the two equations here, doesn't matter which one, we get what? If z is 0, we get, in this case, negative 6x is equal to negative 6, which is going to give us x is equal to 1. Or if we plug in 0 here, we're going to get 5x equals 5, which still gives us x is equal to 1. So we get x is equal to 1. So now we've got our two variables. And so now what we're going to do is we're going to take these two values and we're going to plug it into any one of the three. Now here's the thing. We got to plug into an equation that has y in it. Okay, so in this case here, this one isn't going to work, right? If we plug it in, all we're going to get is a true statement. So we either need to plug it into this one or this one. So all we're going to do is basically use one of these two values, right? So if we use z is 0, that's going to be an easy one. If z is 0, then what do we get? We get 3y equals negative 12. And if we divide both sides by 3, we get y equals negative 4. Okay? So y equals negative 4. Now, if you want to do it the other way, you could plug it into here and plug 1 in for x, and we get 3 here. Or excuse me, I'm sorry, 2. So we get 2 times 1 is 2. And if we subtract 2 from both sides, we get what? Y is equal to negative 4. So we get the same answer. Okay? So now in this case here, what do we get? We get the order triple of what? And we want to make sure we have them in the right order, alphabetical order. So it's going to be 1 followed by negative 4 followed by 0. Okay? So it's always x, comma, y, comma, z. So x, y, z. And of course, we would just put this in set notation. All right, not bad. Have a great day.